Hey folks, Mike Johnson here. If it's got wheels and an engine, you're in the right place. On this channel, we dive into car repairs, maintenance tips, and everything you need to keep your ride running smooth. If you're into cars and want to keep learning, don't forget to hit that like button and subscribe. It really helps the channel out. All right, enough talking. Let's get into it.
If you own a Toyota vehicle, you may come across fault code P1135, as I recently did on my 2001 Tacoma. While it's always disappointing when the check engine light comes on, the good news is that the solution to this code is usually relatively cheap and simple. What the P1135 code on Toyota means. Code P1135 8F sensor heating circuit, bank 1 sensor 1, stored in my 2001 Toyota Tacoma. Unlike the generic OBDI codes, defined by the Society of Automotive Engineers, SAE, P1135 is a manufacturer-specific code. This means that the code is defined by Toyota. P1135 stands for 8F sensor heating circuit, bank 1, sensor 1. The code indicates that the engine control module, ECM, has detected a problem with the 8F sensor 1 heating circuit on bank 1. What is an 8F ratio sensor? All right, that's great. But what is air fuel ratio sensor 1 and what is bank 1? Let me explain. An air-fuel ratio sensor, also called a broadband oxygen sensor, is an advanced type of oxygen, O2, sensor. Like a traditional O2 sensor, an air-fuel ratio, 8F, sensor measures the amount of oxygen, or more precisely, the amount of fuel, in the exhaust stream. The ECM primarily uses the sensor data to calculate the amount of fuel to be supplied to the engine. But whereas a traditional narrowband O2 sensor cannot detect the exact air-fuel ratio, an 8F sensor can do so in most circumstances. The output signal of the two types of sensor is also different. A traditional O2 sensor produces a voltage signal that switches between a lean, lower voltage, and rich, higher voltage, signal, while an 8F sensor produces a variable current signal that increases progressively. Both types of sensor require a heating element to reach operating temperature. The heating element, located inside the sensor, is controlled by the ECM. Modern vehicles are equipped with 3 or 4-wire O2 sensors. The 8F sensor in our Toyota Tacoma example is a 4-wire sensor. 2 of the wires are for the oxygen sensor itself, and the other 2 are for the heater circuit. What does bank 1, sensor 1, mean? The bank 1 part of the code indicates that the problem is with the 8F sensor on the side of the engine that houses cylinder number 1. In most cases, this terminology only applies to engines with a V or flat configuration and 2 sets of oxygen sensors. As for the sensor 1 part of the code, it refers to the sensor located before the catalytic converter. Sensor 2, on the other hand, would be the sensor located after the converter. Fault code P1135 on a Toyota Tacoma. Fortunately, the P1135 troubleshooting code is generally quite straightforward. On my Tacoma, the 8F sensor heater in bank 1, sensor 1 is powered by the electronic fuel injection, EFI, relay. The ECM controls the heater by switching the circuit on and off. Note, the following information is intended for educational and entertainment purposes only. Have your vehicle diagnosed and repaired by a professional if you are unsure of your automotive repair skills. Although the sensor is connected to 4 wires, we are only concerned with the 2 wires going to the heating element at pins 1 and 2 of the connector. The wires are white, W, and white and red, WR, on the harness side of the connector. On the sensor side of the connector, the wires are both black. Spoiler alert, on my Tacoma, I found that the cause of the P1135 code was a faulty 8F sensor. However, there are also other potential reasons why the code may be triggered. The list of common causes includes a faulty 8F sensor, due to a defective internal heating element, a problem with the supply side of the circuit, a problem with the ground control side of the circuit, because most of the time, the problem is a faulty 8F sensor. I started my troubleshooting there. To diagnose code P1135 on my Tacoma, I proceeded as follows: caution, and make sure the engine and exhaust system are cold before doing any diagnostic work on the 8F sensor. Note, the ignition switch must be in the OFF position while performing this test. 1. Set my digital multimeter, DMM, to the ohms setting. Disconnect 8F sensor electrical connector. 2. Disconnect the 8F sensor electrical connector. Connect multimeter cables to 8F sensor connector. 3. Connect the wires from my DMM multimeter to the heating circuit terminals, the black wires, on the sensor side of the electrical connector. Check heating circuit resistance of 8F sensor with a digital multimeter. 4. Check the reading on my meter. On my truck, the reading was above the limit, OL, indicating an open heating circuit and defective sensor. Note, according to Toyota repair information, resistance specifications for heater circuits are 0.8 to 1.4 ohms at 68 degrees and 1.8 to 3.2 ohms at 1400 degrees. A reading that falls outside this range indicates that the heating circuit inside the 8F sensor is faulty, and that the sensor should be replaced. It's important to note that, although code P1135 ended up being a bad sensor on my truck, this isn't always the case. While replacing a faulty sensor is the most common solution for the code, the necessary repairs may differ on your vehicle. Fixing the P1135 code on a Toyota Tacoma. On my Tacoma, the fix for code P1135 ended up being a new 8F sensor. Fortunately, replacing the sensor on this truck is pretty easy, as long as there isn't a lot of rust and corrosion. How to replace an 8F sensor? The tools needed to replace an 8F sensor vary according to the type of car you own. But on a 2001 Toyota Tacoma with a 3.4L V6 engine and automatic transmission, you'll need a 12mm wrench. I used a ratchet wrench. With a flexible head, gasket scraper, penetrating oil safety goggles, scanning tool or code reader, recommended, removing the air fuel ratio sensor, broadband oxygen sensor. Before attempting to remove the 8F sensor, it's a good idea to spray the retaining nuts with penetrating oil the night before. The exhaust components may become extremely rusty and the sensor studs may break. Warning, and make sure engine and exhaust system are cool before proceeding. 1. Put on your safety glasses. Disconnect 8F sensor electrical connector. 2. Disconnect the 8F sensor electrical connector by pressing down on its tab and pulling the two sides of the connector apart. Tip: you can remove the 10mm bolt holding the connector mounting bracket to get a better grip on the connector. Using a 12mm wrench, remove the two 8F sensor retaining nuts. 3. Use a 12mm wrench to remove the two 8F sensor retaining nuts. Remove the sensor from the vehicle. 4. Remove the sensor from the vehicle. 5. Remove the old exhaust gasket. If necessary, you can carefully use a gasket scraper to remove the old gasket material. Comparing the resistance values of the old and new sensors for demonstration purposes, I decided to compare the heating resistance values of the old sensor with those of the new sensor. I performed a bench test to compare the values. Bench test of the old sensor. As you can see from the image above, the old sensor measured OL, indicating an open circuit. New sensor test bench. Meanwhile, the new sensor measured 1.4 ohms, which is within specification, according to Toyota information. Installing the air fuel ratio sensor, broadband oxygen sensor, 1. Compare the new sensor with the old one to make sure both are of the same design. 2. The replacement sensor should be supplied with anti-seize compound applied to its threads. If not, apply a small amount of anti-seize compound to the threads at this time. 3. Fit the new gasket in place. 4. Insert the new sensor into the exhaust. 5. Use a wrench to tighten the sensor retaining nuts. Note: do not over-tighten the nuts. 6. Reinstall the sensor's electrical connector. 7. Use an analysis tool or code reader to erase the P1135 code from the ECM's memory. Note: if you don't erase the code manually, it will take some time for the ECM to clear it. As a general rule, a heating circuit code will take 40 preheating cycles to clear itself. P1135 code patch verification. At this stage, I'm fairly confident that code P1135 has been correctly diagnosed and repaired, but we can verify the fix by checking the O2 sensor heater monitor. You see, clearing the code manually doesn't verify the repair. To be sure that the vehicle is repaired, we need to know that the ECM sees that the problem has disappeared. We can do this by checking the O2 sensor's heater monitor, a system self-test that the ECM runs on the heater circuit. Here's how to check the status of the monitor, a clear code. 1. Clear the code using an analysis tool or code reader. Locate monitor test results via the analysis tool. 2. Display monitor test results using an analysis tool or compatible code reader. On my analysis tool, this information is listed under item readiness when using generic OBDII, but your tool may say something different. The O2 sensor heat monitor is inconclusive because the ECM has not run its system self-test. 3. Scroll down until you find the O2 sensor heating monitor. You'll notice that the monitor is listed as inconclusive, or something similar, because the ECM has not run its heater self-test. 4. Complete the O2 heating monitor control diagram to force the monitor to work. You can find drive model information via an online repair database. According to the information I have from Toyota, to force the O2 heater monitor to work, all codes must first be cleared. You must then start the vehicle and let it idle for 9 minutes. After that, you must drive the truck for 2 minutes at speeds in excess of 25 miles per hour. Meeting these requirements should force the ECM to run the O2 sensor heater self-test. Note, if you do not have access to the driving pattern information, you can simply drive the vehicle until the monitor status changes from inconclusive to OK. The O2 sensor heater monitor now reads OK, indicating that the ECM recognizes that the O2 sensor heater is operating correctly. 5. Make sure that the status of the O2 sensor heating monitor changes from inconclusive to OK, or something similar. This means that the ECM recognizes that the O2 sensor heater is working correctly and that the cart is repaired. Yay! In conclusion, the Toyota P1135 fault code serves as a valuable case study for understanding the complexities of vehicle diagnostics. By examining the symptoms, potential causes, and effective solutions, we can gain insights into how to address this issue efficiently. Whether it's a malfunctioning air-fuel ratio sensor or wiring problems, identifying the root cause is crucial for restoring optimal vehicle performance. Remember, regular maintenance and timely diagnostics can prevent such issues from escalating. Thank you for watching, and we hope this case study has provided you with useful information for your automotive journey.